So I wanted to construct a video showing how we'd find the area between two functions of y instead of two functions of x. And so in this case, it's just a little bit different in terms of how we visualize things, but it's basically the same process that we would use if we were finding the area between curves that were functions of x, okay? And how do we know that we want to use the functions of y rather than the functions of x? So the first thing that I want to notice here, let's say, for example, I want to find the area between the curves y equals x minus 1 and y squared equals 2x plus 6. If we notice here, what we see is that it's much easier to find x as a function of y than it is to find y as a function of x, mostly because of this y squared term. This y squared term actually means that in terms of functions of x, we don't actually have a function of x. This is not a function of x, but it is a function of y. And so consequently, it'd be better for us to utilize this in terms of functions of y. So once we do that, what we're going to need is we're going to need to think about this in terms of y and not instead of in terms of x. So what I've done here is I've actually constructed the graph using Desmos, and I put it on our page. And what you'll notice is that here are the points of intersection, okay, just like we would do in terms of functions of x. But what we want to know, instead of the values for x, we want to know instead what are the values for y. And those are going to be our bounds. And you can actually look here, you'll see that the bottom one is at -2, and the top one is at 4. Now, we can see that in visual inspection, but what if it is the case that we can't actually visually inspect that? So what we're going to do is we're actually going to transform our functions in terms of, we're going to isolate x for both of our functions and then set them equal to each other. So for the first function, y equals x minus 1, we're just going to add 1 to both sides, and what we're going to get is y plus 1 equals x. Then for y squared equals 2x plus 6, what we're going to do is then again isolate x, so subtract 6 from both sides. We get y squared minus 6 equals 2x, and then we'll divide by 2, okay, or multiply by 1/2. And what we end up with is then y squared over 2 minus 3 equals x. So those are our two functions. Those are functions of y, right? The first one, is linear. The second one is actually a parabola. So now what I want to do is I want to set the two of them equal to each other. To find the intersection, set the two equal to each other. So what we have is we have y plus 1 is going to equal y squared over 2 minus 3. Add 3 to both sides. We end up with y plus 4 equals y squared over 2. Multiply both sides by 2. We end up with 2y plus 8 equals y squared. And then what we'll do is we'll subtract over the 2y and the 8. So what we're left with is y squared minus 2y minus 8 equals 0. A little bit of factoring, and we see that this is going to end up being y minus 4 times y plus 2 equals 0. And then that'll tell me that y equals 4 and -2. And so those are going to be our bounds. Notice we didn't solve for x in this case, we just solved for y. So those are the boundaries that we're going to get in terms of the integral. So that's the first thing that we're going to need to find out. What we're going to need to do after that is we're actually going to need to go in and we're going to have to figure out which one's the top function, which one's the bottom function. We can actually look at this and we can inspect it visually. What you want to see is that now we're moving along the x-axis instead of the y-axis. So this is the less than side, right? Going towards the negative, and this one's the more than side, okay? So if you notice, the one that has the negative x's is y squared, right? Y squared over 2 minus 3 equal to x. That's that function there, or this original y squared equals 2x plus 6. And the top function, the one with the bigger x's, is going to be y equals x minus 1. So you can see those and you can inspect those visually and see which one's the top and which one's the bottom. Now, what we'll do is we'll actually do this algebraically to actually confirm that in fact which one's the top and which one's going to end up being the bottom. Okay. So what I'm going to do now is I'm going to look at my two functions. I'm going to look at my two functions. The first one, y squared over 2 minus 3 equals x, okay, and y minus 1 equals x. And I'll pick a number between, pick a number between -2 and 4, so in our bounds, okay? And in this case, I'm going to let y equal 0, okay? Now notice this is a function of y, so I'm going to let y equal 0. So this is going to be 0 over 2 minus 3 equals x. And this will be 0 minus 1, or 0, excuse me, 0 plus 1, that's the function, plus 1 equals x. And so what I'm left with is that x equals 1 for the y plus 1 equation, and x equals -3 for my other equation. The x equals 1, that's the larger value. So this function is on top, is our top function. Now that I know which one is the top function, all that I need to do is I'm going to use what we did when we did it for functions of x. I'll take the top function subtracted from the bottom function. So this is going to give me then the integral, and my bounds now are -2 to 4. That's what I found at the very beginning. -2 to 4 of y plus 1 minus y squared over 2 minus 3 dy. Notice now that it's all dy because we're actually going to be integrating with respect to y. So I'll simplify this. This is going to give me -2 to 1 to 4 of -y squared plus y plus 4 dy. And this then, when we go in and we integrate, we'll use some of our power rules. It's going to end up being -y cubed over 6 plus y squared over 2 plus 4y. And that'll all be integrated from -2 to 4. This will then be -4 cubed over 6 plus 4 squared over 2 plus 4 times 4 minus, and we'll use this, we'll actually do the quantity here in this case. We'll take -2 cubed over 6 plus -2 squared over 2 plus 4 times -2. And this will then equal -64 over 6 plus 16 over 2 plus 16 minus, and this is going to end up being positive 8 over 6, so minus 8 over 6 minus 4 over 2 plus 8. Combining all of our like terms, okay, or they're all like terms. If we go in and we add them all up, we're going to get 8 plus 16 plus 8, that's 32, minus 2, so that's going to end up being 30, minus, and then this will be 72 over 6, which is equal to 30 minus 12, which equals 18. And so that gives us the value for our entire integral. What I'm going to do now is I'm going to actually go through and I'm going to review the process that we had, okay? So what I did was I noticed first that when I looked at my two functions, that one of them was not a function of x, but in fact was a function of y. Or maybe both of them would be functions of y. So consequently, that means that I'm going to want to find the area between two functions of y and not necessarily x. So the first thing that I want to do is to find their points of intersection. To do that, I'm going to write the functions as x equals some function of y, right? And that will allow me to set the two functions equal to each other to find my points of intersection. I find the intersection by setting the two equal to each other, okay? And I came up with the bounds. So those are going to end up being the bounds for my problem, okay? Right? And we can see that as we draw the graph. It becomes apparent as we draw the graph. So now I'm going to go in, and what I'm going to do is once I've done that and I found my bounds, I need to figure which is on top and which is on bottom. I can do that in visual inspection by noticing which one has the lower x values of the two. The one with the lower x values is the quote-unquote bottom one. The one with the higher x values is going to end up being the top one. But I can also do that by a test. What I'll do is I'm going to pick a number between my two bounds, in this case -2 and 4, which is 0. 0 is just honestly the easiest one to work with. So I'm going to plug in that value and see whichever one comes up bigger. Whichever one comes up the larger number for the two functions is going to end up being my top value, right? And the bottom one is going to be the other one, okay? Then what I'm going to do is I'm going to take the integral of the top minus the bottom, okay, which is what I did. And we went in, we integrated and evaluated along the bounds. And that gave me the area between the two curves. So that's it. That's all we actually have to do. I hope this helped. We'll do some more practice with this in class. So yeah, there we are.